Hello and welcome to this very special webinar presented by our friends at Micron Technology and ECS Equus Compute Solutions. Thanks for joining. Our session today is titled The Importance of Storage in AI Infrastructure, and we'll be talking all about AI hardware, things that we've heard a lot about AI recently, AI hardware, innovation, and how you can accelerate your AI solutions. I'm Dean Prine, and I'll be the host today. But now let's go ahead and introduce you to the important people on the webinar today. First off, we have Mr. Andrew Mirau. Andrew is the Senior Product Marketing Manager at Micron. And we also have Mr. Patrick Pedroso. Patrick is the Vice President of Engineering Solutions at ECS. It's great to have you both with us today. Thanks for being here.
Thanks, Dean.
You bet. Thanks. Of course, of course. So let's quickly run down how everything is going to work today and what our attendees can expect. First off, we have Andrew is going to present on the topic accelerating AI with memory and storage. He'll give us lots of great information on AI systems, AI memory and memory implementation, and AI storage solutions. Then Patrick will present on the concept of innovation as a service. Patrick will cover innovation labs, how they work, and how they can be effective in creating AI solutions. We'll also get into a short little Q&A towards the middle and the end. And if you have any questions for the presenters, please go ahead and put them in the chat. With all of that sorted, let's go ahead and jump in. Andrew, the floor is all yours.
Excellent. Thank you, Dean, so much for the introduction. Thank the Equus team, for inviting us to be a part of this today. We're so happy to be here. They're a great partner of ours. And so, as Dean said, we're here to talk about AI. We've been talking about it for, it's been in the news. It's been on the tip of people's tongue. No matter where you go inside of our industry, the joke is how many times will somebody say AI within their presentation? And believe me, you're going to hear it a lot. Over the coming webinar. And so once again, my name is Andrew. I'm the product marketing manager here at Micron. I support our enterprise SSDs. And so we want to talk about, first, we want to talk a little bit about AI, some of the things that are happening in AI, talk about how these AI systems are really created, how data flows through them, and then talk a little bit about the sort of areas that Micron is participating in AI infrastructure. So we'd like to start with this quote. This is a quote from our CEO, Sanjay. It says, "Without data, there is no artificial intelligence." And that truly is the basis of AI, right? You have to have data in order to make, to create these AI algorithms, to infer, from this data and come out with real world results, right? And so, that should make sense in terms of, even human nature, right? We only have opinions, we only have knowledge based off of the data, the things that we see, the things that we hear, the things that we're told. And so with data, when it comes to AI, there's a couple different ways that we like to look at it from a memory and storage point of view. One of the things that we always look at is what we call the mass and velocity of data, right? How much data is there that we need to store, that we need to access, and how quickly can we store and access this data? And when it comes to AI is absolutely pushing the boundaries in terms of the mass and velocity of data, right? When we talk about, say, a typical standard database solution, it may be hundreds of gigabytes to a few terabytes. When it comes to AI, the data lakes that house all of this data can be in the hundreds of terabytes to petabytes to exabytes and beyond. And so it is so important that we have access to this data, but it's more than even just the access to the data. So when we've looked at AI over the years, AI has actually been around for a long time. The term AI was coined over 50 years ago, but there have been parts of AI that have been pretty prevalent in our industry, in our society over the years. When we take a look at the different types of AI, we look at it in two different ways. One is predictive AI. This is the sort of stuff that has been around for a really, really long time. Predictive AI can include things like deep learning, machine learning, handwriting recognition. Handwriting recognition has been around for a very, very long time. You can go back to the Palm Pilots of 20 plus years ago, and there is some level of AI, because AI really is a superset of all of these other different functions like machine learning and deep learning. And so predictive AI, I think, is something that it's easy for us as humans to wrap our head around. It's based off of historical data, right? So one of the things that predictive AI aligns to is, if you've ever been on Facebook, have you ever been on Amazon shopping for something, and it says, hey, you might also like this, or it feeds a video or a reel to you of something that it thinks, you might be interested. The it in this case is AI, right? It's something that's been around for a really long time. And I think for a lot of us, it's very second nature that those things happen. And we don't necessarily associate the modern 2024 term of AI towards these things. What has caught everyone's attention over the past couple of years, though, is generative AI. This is something that it's much more difficult for us to understand what is actually happening here, because generative AI is things like Chat GPT, these large language models where you can go and ask it a question on any sort of topic, and it's going to give you a pretty darn good response. But things like images and videos and things of that sort are really where, AI has moved from, kind of more of a, data scientist analytics side to, you can talk to friends, you can talk to family. My mom knows what AI is. She's heard of Chat GPT. Okay, when you're in storage and memory, there's not a lot of times where your extended family goes, "Oh, I understand what you're talking about." But with generative AI, it is so prevalent now in society that people, they may not understand it to the sort of depths that we're going to talk to, but they understand what it is and what it is doing. And so this is really driving AI as we see it in 2024 and the future. One of the really interesting things that we had, our COO, he actually gave a presentation to the broader company just a few weeks ago, talking about how he wanted to program a little application in a language he didn't know. He actually went and used AI. He used, I believe it was Chat GPT, to help generate code in a language he's never used before. He was able to copy and paste, run some trials, go back and forth, iterate on it, and was able to create a software program solely by using AI and one of these, chat interfaces. So those are the two key ones here that we're dealing with. But what's really important is, and you're going to hear me go back to this time and time again, it is about the data. It is about understanding what the data is and how it flows through your system. And so when we take a look at an AI system, there's really three key points, three key areas that we like to focus on. And the first one is capture. Devices, machines, it's user data. This is, what you see on the screen. Just, it's a drop in the bucket to where data is created. Data is around us all the time. There's, temperature readings, there's humidity, there's visual, there's, all sorts of data that flows around us that is being captured. Now, you can go back 20, 30, 40 years and you started seeing, data becoming available in things like factories, right? Where certain machines were being monitored. It's blown up from there. One of the big, key areas that our industry has focused on over the years is the Internet of Things, IoT. IoT is a great example of being able to capture data, right? Now, what is different when it comes to AI is how we use that data, being able to not only capture that data, but to bring it back, put it in some sort of structure and utilize it and come up with an AI algorithm that really leverages all of that data. So the next step then is organize. So when you capture it, capturing can happen anywhere. It can happen in a data center. It can happen all the way out on the edge, right? There's really no limit to where the data is being captured, but you have to be able to bring it in, put it in a centralized area that you have, large amounts of storage that you can access quickly. You have to be able to label it, prep it, stage it, iterate on it, lots of different things. And label is a big one here. AI is very good with large amounts of unstructured, structured data. but you do have to give it an idea of what it is. So, imagine a 3 or a 4 year old, and if you just kept showing pictures of an elephant, but you never told them what an elephant is, they'll never understand that that is an elephant. They'll understand all these images, and these animals are all the same thing. But until you label it and say it is an elephant, it's hard to understand really what that is. And so, one of the things that we say here is that with the data, it's garbage in, garbage out. You have to have good sanitized data. Otherwise, some of the AI algorithms, some of the results that you get are going to be, in some cases just completely wrong. In other cases, can be incredibly biased. We've seen that. That's one of the big things. If you talk to a lot of industry experts on AI. It's about leveling out biases within your own data, and we're not just talking about demographics or anything like that. Bias can be across all different types of things. So organize is an incredibly important step, and then finally utilizing it. Right? How do we get this data into the servers, into the clusters, to be able to create these AI algorithms, iterate on them, and then come back with an even more refined model. And the utilize part is where we're going to spend a lot of our time here. So on the utilize side, there's two key pieces here that we look at in terms of a system architecture, or steps within the AI process. One is training and one is inference. In training, what you do is you take these large data sets, your hundreds of terabytes, petabytes of data, you run it through these models, to teach a generative AI or a predictive AI, to recognize these patterns and generate new data. The challenge is that training servers require a lot of memory, they require a lot of storage, they require a lot of compute, and they all have to interact really cohesively, right? If you overextend any one piece, you're not going to get the sort of results that you expect. If you underspend in one area or you under specify in one area, you're not going to get the results you expect. So the first step in AI is training. It's to create that algorithm, right? The second piece is inference, right? Where instead of always referencing back to that massive data set, what you're doing is you're taking in new information, right? And you're running it through the AI algorithm to generate a new result, right? So things like ChatGPT, what you run on in terms of your web browser, that's more of an inference. You're providing it new data. It's coming back with a new result, right? But when you go from the underlying technology, GPT-3, GPT-4, and beyond, that's more on the training side. So first you train, then you infer from that training. And as we move on in this discussion, you'll see why there is a difference there when it comes to the system architecture. So just to give another example, this is one that we've actually worked with. We were working with a university in Europe on medical imaging, and this is one a lot of people like to share the same sort of thing or the same sort of example, because it's so prevalent right now, but it is so important. So it's medical imaging. So in the past you would take in, if you were a doctor and you took a look at a skin condition. Is it a melanoma? Is it benign? Is it malignant? You really didn't necessarily know what that is. And so what these universities, and in the medical field, what they've done is they've taken hundreds of thousands of pictures, of scans of these type of growths, right? And then they organized it. They said, was this benign? Was this malignant? That's the key part, right, of telling which is which. And now what they can do is that they can go and run inferences on that. So doctors now throughout the world can put in pictures and have a very high level of certainty of, is this benign or is malignant? And AI, it was the absolute key to doing this. And not only, obviously AI was the key, but also storage and memory. So at the start of this, this specific example, in order to iterate in that AI training model, the data was being pulled off hard disks. Okay. And it took something like 10 hours to pull the data sets in, right? So when they would go in, they would tweak their algorithm, have to pull the data sets back in, 10 hours, right? They switched to SSDs. They brought it down to under 2 hours, right? So you can see that cycle time where you literally got maybe one training session per day. You'd pull it in, you would run it, you would come back the next day, right, in order to see the results. By moving to SSDs, they were able to reduce that cycle time immensely so that they can actually iterate and refine the AI algorithm in the training session. And now, they're able to deploy that to a lot of different doctors and hospitals around the world. And so this is one example of AI. I think we could spend, the next 8 hours going over all of the different examples, but this helps give you an idea of that difference between training and inference. So when we break it down even a little more, now let's take a look at how memory and storage are giving us the ability to really supercharge and push the boundaries of AI. And so when we look at memory and storage, we view it as a pyramid, where near memory is the closest you can get to compute, where networked data lakes are really where you store the vast amounts of data. The key to AI is being able to get that network data all the way to the top of the stack as quickly and as efficiently as possible. And so when we take a look at near memory, these are things like high bandwidth memory, GDDR. These are not products that we sell like, on a in an enclosure that you just plug into a system. These are chips, right? These are chips that go and sit right next to the GPU. So if you buy, say, for an example, an NVIDIA GPU, you're going to probably have GDDR or high bandwidth memory as a part of that. Micron is a part of that. And this high bandwidth memory is so vital to being able to enable large language models, training, inference. All of these things are required, because when we talk about HDDs, you're talking about maybe 100 megabytes per second of data rate. When you take a look at an SSD, you're talking about gigabytes of data rate. When you get all the way to high bandwidth memory, you're talking about over a terabyte of memory bandwidth per second. So near memory is one that is absolutely required as a part of the AI. Now, as we move farther down the stack, we have main memory. This is, host memory, the DDR4, DDR5 that we know and love. AI is absolutely pushing the adoption of DDR5 in our industry, because the more memory and the more memory bandwidth you have, the faster that you can feed those GPUs, right? The faster we can get to the top of this pyramid with our data. Next, this is a new tier. This is a new class of memory, or a new classification of memory that we have that's called expansion memory. It is part of the CXL specification. So imagine taking DDR memory, but instead of having it on the memory bus, you have it on the PCIe or the IO bus. What that does is it allows you to expand beyond the limitations of host memory. So if you're deploying a server, maybe you're limited to 768 gigabytes of DRAM, or a terabyte, or 1.5, or whatever it is. With CXL, you can start at a terabyte level. And so this is a technology that Micron will be supporting in the channel later this year and early into next year. Starting at capacities of 128 gig, which, to give you perspective, DDR maxes out right now for Micron at 128 gigabytes. So expansion memory, or CXL, starts at that and will go on. And then finally, we have local SSDs. These are the NVMe SSDs that have been around for a very long time. We're in 2024. NVMe, although in some areas it may sound new, NVMe has been out for almost a decade at this point. It was released in the summer of 2014. And so NVMe SSDs have been around for a very, very long time, but they are extremely important to the local caching that is required for an AI solution. And then finally, we have data lakes, or network data lakes. This is where you're talking in the hundreds of terabytes and up. And you need two key things here. You do need performance, right? Because we want to make sure that we're pushing that data up the pyramid. But we also have to be cost effective, right? And this is what has kept SSDs out of the network data lakes up until the last year or two, is purely in the cost, right? HDDs certainly have a lower cost per gigabyte. But what we found is that as all of the other layers of the pyramid got bigger and faster, it got to the point where HDD-based networked data lakes could not keep up. And that's a key thing that we always want to stress and we always want to talk about, is that the goal of memory and storage at an infrastructure or an architectural level is to get data to the GPU as quickly as possible. Okay, GPUs are enormously powerful. They're enormously expensive, and some, depending on the time of year and what year it is, they can be very difficult to find and procure. Right? They are a very important part of the AI system, and so what you don't want to have is an incredibly expensive and incredibly rare GPU sitting idle. Because you're waiting on a hard drive to feed it data. So you don't want to spend a whole lot of money in the top of this pyramid if you're not going to specify in the right type of storage at that network data lake. So when we align this with Micron's portfolio, we just want to spend a few minutes here talking about the portfolio. We have 4 key areas that we focus on in terms of data center AI storage solutions. Over on the right, the one that's grayed out, it's grayed out for a reason. We do have a line of SATA SSDs. In general, though, SATA is not a great fit for AI solutions. They could possibly be usable in things like an AI data lake, but because of their maximum capacity of 7.68 terabytes, it's going to take a lot of drives to really scale to where a lot of these AI solutions are. The performance is probably okay for certain types of AI solutions. It's certainly an order of magnitude better than a hard drive. But really the capacity is what's limiting it. And so really when we talk about AI on the storage side, it is about PCIe and NVMe technology. And so starting on the left, we have our high performance 9000 series. Our 9000 series is our highest performing product out there. This line of product is where you see the new innovation, the new features, the newest interfaces. And this is the area where when we take a look at local storage, this is a great product to feed that data into, into main memory and into the GPUs. Next, we have our mainstream line of SSDs. This is our 7000 series. Really flexible option. It's a balance between performance, features, and cost, right? So it's not going to have quite the same performance as the 9000 series, but you're going to get more options in terms of form factors and capacity points. And then finally, we have our 6000 series. This is our high capacity NVMe SSD. This is absolutely made for these network data lakes, right? As we've seen the growth of AI over the past couple of years, we have seen enormous growth in our 6000 series to the point that it is our fastest growing, fastest ramping SSD that we have ever had. And I can say with absolute 100% certainty that it was because of AI. If AI wasn't there making these large requirements on the system in terms of storage and memory, we wouldn't be in a position we are with the 6000 series. The 6000 series is great in terms of, or because of the fact that it's high capacity. It's a 30 terabyte option. If you remember the old Henry Ford quote, you can have the Model T in any color you want as long as it's black. Well, you can have the 6000 series in any capacity you want as long as it's 30 terabyte. Because with these AI data lakes, we have found that 30 terabyte is absolutely the sweet spot for that. The other side of this is that this is a value-oriented solution. So this is going to come in at a lower cost point than the 7000 series and the 9000 series. The way we look at it, one of the questions we get asked, they go, well, is the 6000 series ever going to displace hard drives? And the answer is no. I don't believe that I will be around when HDDs eventually go away, simply because there are still a lot of companies making tape backup systems, right? Tape backup goes back many decades, and it's still around. And so hard drives will always serve its purpose. What we like to think of the 6000 series is not displacing hard drives, but enabling these types of AI solutions that would not be possible if we only had hard drives. And so really exciting product portfolio for us. We're incredibly happy with where we stand and how competitive we are in our industry. We feel like we can really go into any situation, but specifically AI discussions with a strong portfolio. So breaking it down even more. So we talked about training, inference, we've talked about data lakes. How does this kind of all fit together? So we'll start with AI training. These are, a high density AI optimized server. You typically have a 1-to-1 ratio between GPUs and SSDs. Um, as a part of that, you also have networking, you have CPUs, you have main memory, DDR5, and possibly CXL as we move, as we advance over the next couple of years. This is the sort of situation where we would always look at our 9000 series, specifically the 9400. As you saw, it also goes up to 30 terabytes, but the key part of the 9000 series is performance. So you get sequential reads and writes of 7 gigabytes per second. We're the only one in the industry that has balanced input and output. The reason why this is so important in the AI model is that you can be ingesting data from your data lake at the exact same speed that you are pushing it back out to your GPUs. It gives you a balanced system. Really, no other SSD in this class on the market is able to do that. And so we always look at the 9000 series. And to be clear, we're talking really specifically on storage. But as we showed in the pyramid, we are participating in the CXL market. We are a major player in DDR5. And even those GPUs, even though they don't say, it's not a branded Micron product. We don't do the compute side of it. We do sell our high bandwidth memory into GPUs, and it is a large part of our portfolio and expected to be an even bigger part over the next few years. And so that's the AI training server. So if you go back over the last couple of years, AI training is when somebody said AI, this is the sort of system they were talking about. What's evolved over the last few years is the propagation and the growth of AI inference servers. So remember, inference servers aren't creating the model. What it is it's taking in new data and generating a result. And so instead of a 1-to-1 GPU to SSD, it's more like 1 GPU to 6 SSDs. You don't have nearly as much networking, DDR, you don't really need expansion memory, anything like that. And so for that, our mainstream NVMe products are certainly a great fit here. The Micron 7450, the Micron 7500, you can get up to 15 terabytes. You do get fairly high performance, but you don't get that same balanced reads and writes that you see on the 9400. The reads are certainly there, but the writes are a little bit lower. The thing about AI inference is so interesting in the fact that we're representing it here as a server. AI inference doesn't necessarily need to be a server in a data center. It can be a server out on the edge, right? It can be a ruggedized PC. Eventually, you're going to get AI-enabled PCs. You're going to have AI-enabled cell phones. As long as you're able to get the compute to a certain level, lots of different things can be an inference server. So AI inference, I believe, is where there's going to be just massive growth over the next few years. And then finally, we have the network data lake. You can see two key pieces to a network data lake is a lot of performance and a lot of networking, or excuse me, a lot of capacity and a lot of networking. And the 6500 is a great fit there. You still get very good performance, 6.8 gigabytes per second reads, 5.6 gigabytes per second writes. Just a few years ago, that would have been a performance SSD. Now it's a high capacity value SSD meant to scale out into these extremely large data lakes. And so wrapping this all up, wrapping up my section here, the question is why do we care? Why do we care as a supplier? Why does Equus care as one of our partners? Why should you care as an end customer? The reason why we care about this is because of the reliance of AI on storage and memory. AI servers can have up to 8 times the amount of DRAM, 3 times the amount of NAND, right? So these solutions are just inherently, and this is more of a representation of an AI training server, but you'll see it to a similar extent even on the inference side versus a general purpose server that you maybe just are running a database off of. So the reason why we care is that these sort of systems really are heavily there's a heavy requirement on storage and memory. Our partners should care too because these are the sort of systems that are showing immense growth. We're going to have a report that's coming out here soon that between 2023 and 2027, the CAGR on AI servers is going to be 26% in a market that, in terms of units shipped, is going to stay fairly stable with low single percent growth over that same span. And the reason why, it's so important for a company like Micron to partner with Equus is that, we can talk and we can have these conversations and we can talk about the importance of storage and memory. But what's really important is tying it all together to make sure that for your specific use case that you are getting the right amount of DRAM, you have the right amount of storage, you have the right amount of compute. If you don't, you're going to be put in a position where you're over specifying a solution, so that means you're paying too much, or you're under specifying it and you're not getting the results you need. So when we talk about, the importance of memory and storage and where we feel our place is as a part of AI, we want to be very clear that it's not just Micron. It is the NVIDIAs of the world. It is the Equises of the world. It is OpenAI and all of the different software platforms. It is things like software-defined storage and how the data is stored. There's a lot of different pieces of it, but you need somebody, you need a trusted advisor to help walk you through this, because it is incredibly complicated, more so than, over the years we've talked about things like virtualization in the cloud, and those things are certainly complicated, but not to the level that AI is. And so, we're happy to have this time here with Equus just to share a little bit of insight on where we think the AI market is going and where we fit into it. And so, to close up my section, if you want to learn more on the Micron side, please visit micron.com/AI. And because it's an AI presentation, I'm leaving you with an AI graphic that was generated purely through prompts, in an AI system. And this is what it spit out. It looks pretty nice, but we can't close without an AI graphic.
Awesome, Andrew. Thank you. I think it's easy for folks, or maybe it's fun, but it's easy for folks on the outside to kind of see AI as magic. But the reality is that if it is magic, then you guys are the magicians. Because there's definitely a lot of stuff that has to happen in order for the pedestrians like myself to have the fun and to see the magic.
Yeah.
So thank you for letting us peek a little bit behind the curtain.
Dean, what's the quote? Is that a substantially advanced technology is indecipherable from magic? I know I butchered that quote, but that's kind of what we're looking at. And to your point.
Yeah. No, it is absolutely true. And as you might imagine, we do have a few questions for you. To start really quickly to keep things going, how does storage technology impact the total cost of ownership of AI infrastructure, including factors like hardware investment, maintenance, and scalability?
Yeah, that's a great question, because look, hopefully what everyone gleaned from that last slide is that, look, AI deployments they're not cheap. They require an immense amount of hardware. They're very expensive to deploy. And so you have to look at things like total cost of ownership. So going back to my example is that if you don't right size every part of that pyramid, along with networking and compute and the other pieces, what you're going to have is an inefficient or an unworkable solution. We've had multiple times that we've actually went in with customers and they have said, look, I put the latest NVIDIA GPU in and I'm not getting the results I wanted. Well, the issue is that the GPU was sitting idle 70, 80% of the time because they were waiting on memory and storage. And specifically, in most cases, it's hard drives, right? Their data lake was sitting on a hard drive and it was idling the entire rest of the system. So in terms of hardware investments, you want to make sure that you're right sizing every piece. Otherwise, your ROI, expanding on TCO, your ROI is not going to be where you want it. And then the other piece of it is certainly scalability. So, when you look at things like a data lake, right now, Micron, we have 30 terabyte SSDs that are in a 2.5-inch form factor. I believe the highest density HDD right now is 24 terabytes in a 3.5-inch form factor. So what does that mean? With SSDs and partnering with Micron, you can get higher density solutions per U, per server, per rack. And when you're able to do that, you're able to eliminate additional racks, additional servers. As a part of that, you eliminate power supplies. You eliminate a lot of the power obviously needed to go to power those things. And then even things at a facility level like cooling, right, is an important part of total cost of ownership, where SSDs, as a part of AI, since they're so large, a lot of these different pieces are going to become even more important.
Excellent, very good. I know we got to keep things moving, but we do have one more question for you. Can you also explain the role of data management plays in maximizing the value of AI initiatives, and how can storage technology facilitate efficient data governance, access, and lifecycle management? That's a mouthful. You got 2 minutes.
I got 2 minutes. All right.
Let's have it.
All right. I think I can do this. So a lot of this goes back to what we are talking about in the pyramid. It's about the flow of data, because even though we're a very memory and storage centric company, obviously, the role of data management within an AI system is how quickly can I get the data to the GPU? The GPU is in some cases an order of magnitude more expensive than any other individual part of the system. Idling it is incredibly inefficient. And so understanding all of those different steps, and managing that data, right? Because even once you say, all right, I've architected the right pieces, what do I need from a software side? What sort of software-defined storage do I want to work with? Is it going to be Weka? Is it going to be Ceph? Is it, there are a ton of different options out there. And so data management is incredibly important. And access really is, when we talk about access to data, going back to the very first point we made in this presentation about data, it's about mass, it's about velocity, right? And so if you cannot create and get to an equilibrium, a balance with all of those different pieces, you're not going to have an efficient AI system. And to be honest, I believe that data management and data flow through the system, not only, as I said earlier, is one of the most difficult parts of an AI infrastructure design, you know, it's the most difficult, and probably the it takes the most knowledge, right? It's one of those things. It's very difficult to stumble into an AI architecture. So if you don't have that sort of knowledge internally, you need to partner with an Equus in order to be able to efficiently deploy these types of solutions.
Excellent, Andrew. I think that's the quote of the day. You cannot stumble into an AI architecture. Very good. Thank you so much. Patrick, it's your turn. Patrick Pedroso of ECS. Please have at it.
Thanks, Dean. I appreciate it. And Andrew, thank you. Yeah, Dean, it's not magic. It's innovation. Micron is adopting all the new technologies and moving forward with their hardware. We are here to basically help right size that and help the customer move along in AI. So innovation is the topic I would like to share with everyone today. We actually provide it as a service. We're helping our customers, with individualized computing, data center infrastructure, liquid cooling, AI enablement, which is a big part here with our partner Micron. We work with telecom systems and 5G. We have our innovation center is actually located in Southern California. We are hosting several different systems with Micron hardware, NVIDIA, Intel. We basically bring all the functional parts together so that you can develop your products. The way we help, the service that we're actually providing you is through the system design. We want like Andrew was saying, we want to right size. We want to integrate everything together, help you with the pieces and the parts and the software to help move, the progress. The Innovation Center is located in Southern California. We are in process of expanding to the East Coast and various other locations. We have program management also to help kind of develop, customized plans to help you develop your products and solutions. We have a project management team that will help you. We'll work side by side to develop your products for you. And also we help with deployment and installation. We have global resources for stocking, service. We have a global NOC to support. And we also, we can help with, we also have AI in our website to basically help with supporting customers as they have individual questions that come up. So we've been we use a bespoke design process. We can do customize systems, hardware. We build out. We're vendor agnostic. We don't specifically have we work with Micron, we work with Intel, we work with NVIDIA to develop a custom tailored solution. We are more for the right tool for the job. So we work with many different providers to help move the project along. We've got about 34 years of engineering experience, 35 now. We've delivered over 3.5 million systems. These are all, they can be anything from custom systems to modified systems from Dell, HP, Lenovo, whatnot, and Supermicro. We have a highly skilled and trained workforce that can adapt and design the systems for you. Our global footprint, our headquarters currently is in Minnesota. The Innovation Center is in California, Southern California, City of Industry, if you know where that is. We also have support offices in Germany, Brazil, China, Taiwan, and Japan to support our global customers, along with several stocking locations if we need to help with delivery. We have partnerships with widely recognized brands, Micron, for instance, and several others. Our continuous, we have a continuous drive for synergy. So we believe in 1 + 1 is greater than 3. So we want to be your trusted advisor. We have a deep experience, with multiple different verticals and technologies, different storage technologies, different GPU technologies, software, you name it, and we can integrate it. So this is the process we use to kind of develop out our solutions. We do a formal needs analysis. We do a best fit selection that involves the right pieces, the right tools. It involves getting the correct hardware and software together. We do price optimization and performance optimization, meaning, if you need the 9,000 drives or the 6,000 drives, we'll help you optimize that. We also, after we've done that, we tailor a complete system. This is from the baseboard up, all the way out to the cooling technologies that we use and such, along with security and different applications that sit on the actual system. And then the final process is benefiting from it. Your customers will benefit from our services and then the added value that we've done to right size it for them. And these are the things that we can do. We help with product selection and procurement. We have a full team for that. We have a strategic procurement team. The hardware, software, design, and fulfillment, we have a full engineering staff to help with on both the hardware and software side, as far as applications and firmware to components and chassis. We custom tailor off-the-shelf configurations. We can do full rack integration. Like I mentioned, we had our innovation center. We do a full infrastructure design. So if you need assistance with the infrastructure itself, the power, the cooling, the cabling, whatnot, we can help you with that. We provide the integration of all that. We provide the deployment services as well. We also have supply chain management for dealing with those issues where we can't quite get a product. And we have folks that are specialized in that to help us get products. We have our own personal break fix support. So we do have a 24/7 knock and a fully staffed follow the sun technical support team. And this is kind of going over the innovation as a service. These are the formal offerings under that. We integrate, we help with the integration and the deployment. We help with AI. We help with 5G. We have a 5G core in our innovation center where you can do your testing for 5G. We also offer infrastructure as a service. So if we need to add additional systems or additional bandwidth or whatnot, we can modify the infrastructure as we need to. We help with the hardware design, primarily chassis components, all the way down to board level design. Software engineering will help with application development and firmware. Our ESG as a service is kind of a new thing that's come recently. The new requirements now are how your company is performing, not only on a performance level, but also on a environmental level, and we'll help you provide a scorecard for that. We provide immersion cooling for those folks interested in getting into higher density solutions. We offer cybersecurity through our partner Zscaler. We have a network operations center that I mentioned, and we have an executive briefing center where you can actually share your products with your customers. And here are some of the specs on our innovation lab. It's approximately 95,000 square feet. We have the latest technology in there. We've been working with Intel on a Gaudi 2. We've been working with NVIDIA on DGX. We have, of course, Micron storage technologies. And we also have a plethora of other interesting technology that we can help you with. We have a customer demo and POC services. So we do have staff that are capable of helping with the POC, not only creating it, but also delivering it if you need help with that. We have all of our hardware is on-prem. We don't source out to AWS or any of the other services. Everything is there. So, if you need to come out and see the hardware, or if engineers need to work on site, we have that available. We provide dark instances. This is basically where, there's no access and people can work securely. They don't have to worry about any other folks getting in or penetrating that environment. We also have the AI ML gear, of course, that I mentioned. And we have appliances that we can deliver to basically serve as a gateway or for like retail locations. They can hold multiple applications and also protect different sites. And of course, we have immersion cooling and tanks. And this just kind of goes over our innovation center again. Fully remote access, immersion cooling. Your hardware engineers can also be on site working next to our engineers to develop your products. Zscaler is a big partner of ours. They help with the security side so that everything is kept within the zero trust circle. This goes into the liquid cooling. We have multiple, direct-to-chip options. We have rear door heat exchangers. We have a single phase immersion cooling or dual phase, depending on what you would like to test there. We have our micro data center. What that is basically a containerized data center where we can basically drop it in to your site and basically provide, either temporary or permanent expansion to your compute or GPU needs. We have PUEs as low as 1.013. This is accomplished via the reduction in the infrastructure supporting and also using immersion technologies. We have rapid prototyping and development. We can help build the product in our innovation center, send it out to our production line, and then actually have it built and ready for deployment, all in the same facility without having to send it out or go through another third-party entity. We do brownfield remodeling. Basically, we can adapt an existing site to accommodate liquid cooling. And then, of course, greenfield architecture deployment, we can also help build and design from the ground up your immersion solution. And then I think the very important thing here, we really haven't hit on it too much, is security. I think some of the things when you have this much data, keeping it secure is very important. Like I said before, we have partnered with Zscaler. We basically have an appliance that basically we use their zero trust exchange to kind of keep all of your data and all of your information and your transactions and your development on a secure and separate network, from the cloud. All right. So in closing here, a few of the key areas that we want to focus on are our bespoke appliance design, our platform as a service. We're a full stack, either application or network stack. We're fully supporting you. Our infrastructure design and deployment, our software hardware optimization, and our liquid system integration, and of course, our generative AI knowledge and expertise. And these are our partners that we work with. And if you'd like to learn more, you can visit our website, equus.com. Thank you.
Awesome, Patrick. Thank you very much. Truly where the rubber meets the road between what Andrew was talking about and what it is that ECS is doing. Very fascinating, gentlemen. Thank you. Attendees, if you have any questions or would like a demo or want to learn more about what Andrew and Patrick have presented here today, we'll be sending you, good news, we'll be sending you the webinar along with our contact information so you can revisit at any time. But before we go, gentlemen, really quickly, in fact, 15 seconds, one last question for both of you. Looking ahead, what trends do you foresee that will further revolutionize AI infrastructure and empower organizations to unlock new insights and capabilities? So future predictions. Patrick, you go first.
Sure, Dean, thank you. So yeah, some of the trends that we're seeing are, you need definitely a cloud, data management, managing all the data, and you can't have disparate tools for that. You kind of got to have an all-in-one solution, a software application that can kind of manage all that data and keeping it clean, making sure that it's accurate. I think that's going to be a really important going forward. As the AI and machine learning expands. And then also prioritizing the data security. That's very important. That's why we partnered with Zscaler to, kind of keep everything encapsulated to secure your data and also feed the AI systems.
Excellent. Andrew, your prediction.
Yeah, I mean, a lot of what we're doing on the storage industry side, I would say, is much more evolutionary, but AI is certainly pushing the pace of what we're doing things. But one of the things that I want, on a piggyback on what Patrick was showing is things like liquid cooling that have technically been around for a long time, but we're seeing a lot of interest, a lot of major advances. I've actually been to ECS's innovation lab. It is awesome. It is state of the art. They do a lot of great stuff there. So it's great to see all of the stuff that they're working on and helping guide these customers, through their AI journey. So excellent work.
Very good. Gentlemen, thank you very much. And once again, thank you to our attendees and to you, gentlemen, our presenters. This has been The Importance of Storage in AI Infrastructure, brought to you by ECS, Equus Compute Solutions, and Micron Technology. We'll see you soon.